Okay, so our first step is to hypothesize. We're going to state our hypothesis about the population parameter. When we're going through and we're working on this hypothesis, it's always going to show up in a pair of hypotheses. So Merriam-Webster's dictionary defines a hypothesis as a tentative claim made in order to draw out and test its logical or empirical consequences. So again, as I just mentioned, we're going to have a pair of hypotheses that we're going to be writing for all of our problems. It's going to consist of a null hypothesis and an alternative hypothesis. The null hypothesis always gets the benefit of the doubt throughout the hypothesis testing procedure. We only reject the null hypothesis if the observed outcome is extremely unusual if the null hypothesis were true. Thinking about our null hypothesis, it's analogous to assume that a defendant in a jury trial is innocent until proven guilty beyond a reasonable doubt. So the idea is we're going to assume that the null hypothesis is true, just like we assume that the defendant is innocent until proven guilty beyond a reasonable doubt. So if we end up with extremely unusual results here. Our hypotheses are always about population parameters. They're never about sample statistics. So we're going to see that notation as we go through here. All right, so our null hypothesis, we have an H with a subscript of a 0. Our null hypothesis is pronounced H naught. It is a neutral status quo skeptical statement about a population parameter. It always contains an equal sign. Our alternative hypothesis is the research hypothesis. It's the statement about the population, the parameter that we intend to demonstrate as true, or maybe we can't demonstrate that it's true. Our alternative hypothesis we call HA, so we call them H naught for the one with the sub-0 and HA for our alternative hypothesis that has a subscript of A. Our alternative hypothesis always has a less than, a greater than, or a not equal to sign. So our null hypothesis has an equal, our alternative hypothesis has a different sort of inequality sign. Right, so when we're looking at our pairs of hypotheses, we could have a one-sided or a two-sided hypothesis test. So there's basically 3 different pairs of hypotheses that can be used. All right, so our two-sided test, our null hypothesis is P equals P naught. Again, we use P naught and P because we're thinking about population parameters, not sample statistics. And if we look at this, our null hypothesis is actually the same in all of these cases. What makes this particular one a two-sided hypothesis test is the not equal to sign. So when we're thinking about this, we have 2 tails on either end that are going to be in question. A one-sided, we can have to the left or to the right, and they're going to have either a less than or a greater than sign in their alternative hypothesis. So in all of these cases, our null hypothesis has a subscript of 0. Right? So it's our H naught, and our alternative hypothesis has a subscript of A. That's our HA. H naught always has an equal sign. HA can have one of 3 different symbols, making it either a two- or one-sided hypothesis test.